everyone, this is question 8 from your homework on chapter 5.4 integration formulas and the net change theorem. So the question says a ball is shot at an angle of 45 degrees, which I denoted with theta, and we'll use the same formula regardless of how many degrees the ball is thrown into the air with initial velocity of 40 feet per second. And again, I denoted that with v naught because for some of you the initial speed might be different. And then, assuming that there is no air resistance, we are asked to find how high does the ball go and how far away it lands. And we're given a hint that the acceleration due to gravity is 32 feet per second. So if you look at the little drawing I did on the bottom, the ball starts here. It is thrown at a degree theta, and then it travels at a parabola until it reaches the highest point over here, and then it keeps moving until it lands down on the ground. And we are asked to find what is the maximum height that it went, and also what is the distance from where it was thrown to where it landed. And if you notice right here, we have a right triangle with the theta, where the theta is the angle where the ball was thrown, and the hypotenuse is basically how far the ball have traveled, because it was thrown with initial velocity of 40, or v naught in this case, feet per second, and it traveled t seconds. So based on that triangle with the hypotenuse v naught times t, we can find that in the x direction, depending on time, the ball will travel v naught times t, which is the hypotenuse times cosine of the angle theta. And then into the y direction, we can do the same thing. It will be v naught times t sine of theta. So basically, again, look at the triangles. The one that is corresponding across from the angle would be the sine, which is for the height, and the one that's adjacent will correspond to the cosine, and that would be into the x direction. However, when we are up here for the height, we also need to account for the acceleration due to gravity, which from physics we know is minus g over 2 times t squared. And again, when we are at the ground level, there is no acceleration due to gravity, so we don't need to do anything for the x. And now, based on the numbers that we were given into this question, we can compute that x of t would be 40 times t times cosine of 45 degrees, which is square root of 2 over 2. So we have that 40 t times square root of 2 over 2, which simplifies to x of t being 20 square root of t, square root of 2 times t. Doing the same thing, so this is how far we travel into the x direction. The same thing for the y direction, we can find that this is 40 times t times sine of 45 degrees, minus, we said that g is 32 divided by 2 times t squared, and by simplifying this, we get that y of t equals sine of 45 degrees is again square root of 2 over 2, so we gotta get 20 square root of 2t minus 16t squared. And then for the first question, or part A, was asking for the maximum height, which we denoted height with y of t, so we need to maximize y of t in this case. And if you remember, when we are maximizing something, we need to find the derivative and set it equal to 0. So we are doing y prime of t, and that would be 20 square root of 2 minus 16 times the derivative of t squared is 2t, that will become 32t, and we're setting this equal to 0 and solving for t. So that would give us t being equal to square root over 32, which we can simplify a little bit by dividing the top and the bottom by 4 to 5 square root of 2 over 8, which is approximately 0.88. But I'll still use that number just because of calculation purposes later. So to make sure that this is a maximum, we can plug in this value on a number line and compare the signs to the left and right of it. So let's say, for example, t is equal to 1/2. So if we plug in 1/2, we're plugging it here at the derivative, we'll have 20 square root of 2 minus 32 times 1/2, which would be a positive number. And again, we can also plug in 1. We'll get 20 square root of 2 minus 32, which is a negative number. So here we see that the function is increasing, here is decreasing, which gives us a max at t equals to 5 square root of 2 over 8. And again, we are not asking when the maximum is, but how high it was. So we need to plug in that value back into the height function, which would be y of 5 square root of 2 over 8 would be 20 square root of 2 times 5 square root of 2 over 8 minus 16 times 5 square root of 2 over 8 squared. And simplifying that, we'll get 20 times, so that would be 200 over 8 minus 16 times 2550 over 64, which would then give us 25 minus how much is that? 25 over 2, which would give us 12.5, and this is height, so that would be in feet, is the maximum distance that the maximum height that it went up. For the second question, it is asking about when was how far away it went into the x direction. So if you look again here at the picture, over here we can see that we are at a height 0. So basically what we need to do is take the height function, which was right here, y of t, and set it equal to 0 and solve for t. Again, don't forget that t needs to be greater or equal to 0. I mean, if t is equal to 0, we will be basically at the beginning when we throw the ball. So solving this, we see that we can factor out maybe 40 from both of them. So here we'll be left with 5 square root of 2. Here we'll be left with 40 equals to 0. That would give us t equal to 0 or t equals to 5 square root of 2 over 4. And again, at t equals 0, we are basically at the beginning when we are throwing the ball, so we'll just use the second time. So that means that the ball would hit the ground again at t equals to that number. And again, we are plugging this into the x function that gives us the displacement going into the x direction, which was 20 square root of 2 times t. And solving that, we get 50 feet into the x direction. And this is the solution for question 8 from chapter 5.4. Thank you.